Good morning. So we introduced Gary. Gary's from our base maintenance division, and which is responsible essentially for the hangar maintenance of all Delta aircraft and all Delta customers. And I'll talk a little bit about that in a minute. I also have here Matt Sparks. Matt, can you raise your hand? Matt is a director in line maintenance at Delta, and he's been involved for probably 5 years now with realization and the initiatives that we've done with realization. So pleased to have both of them and a lot of experience here. So I think in the intro we covered a little bit of Delta and the relationship of Delta Tech Ops. Just a couple of points. I think if I talk about Delta and you see all the stats up there about 2,500 departures a day and 80,000 employees, it's important to point out that this is in reference to the post-merger Delta. So if you'll remember back in 2008, Delta and Northwest Airlines merged. And I think that's important to remember because you'll see up there we have 13 different fleet types that we're operating. And so while one of the great synergies of an airline merger is potentially getting your network optimized, so combining two networks, we were able to do it, and we're trying to look at the positive side of this, we were able to do it with varying different gauges of aircraft. So between Northwest and Delta, we shared only one common fleet. So each airline had a very different, disparate fleet of aircraft, and putting those two fleets together resulted in, good for the network and good for the flight schedule, able to optimize revenue, maybe not so good for the maintenance side because we have 13 different fleets that we have to try to maintain, and that'll become important as we walk through this. So Delta Tech Ops really, you would call it Delta's maintenance division, but it's more than that. Delta Tech Ops has taken a different approach, maybe than the normal way of doing business, and that is we've decided we can really grow it into a third-party maintenance, repair, and overhaul business. We've got over 150 customers. We have almost 10,000 employees. We've grown this from, in 1999, we first started to dabble in doing work for other people, and at that time we did $19 million in third-party revenue. Last year we finished well over $500 million, and I think that my boss, Tony Sharaf, has made many public statements about growing it to $1 billion in third-party revenue, and we'd really like to be able to deliver that for Delta. So let's talk a little bit about sort of the three different parts of Tech Ops. If I were to just divide it into three big categories, there's an engines and components group, and just as their name would imply, they're responsible for the engines, the components, anything that sort of unbolts from an aircraft. This is done in a shop environment, fairly controlled environment, and we engaged Realization for some help in improving our capacity, improving our turn time, increasing our throughput back in the 2007-2008 timeframe. And we show the results here, and they were really phenomenal. 23% increase in engine production. So on the same capacity, we're able to move 23% more engines through the facility. 30% reduction in turnaround time. Turnaround time on an engine asset can cost anywhere between $2 and $20 million as it, just the cost to own that asset. And reducing the turnaround time either for Delta or for our customers is can materialize into real dollars in having to own less assets that you have in work at any given time. And then over the time period that we did the implementation, an astonishing 73% increase in revenue. So a real success story and a great partnership with Realization that really began at that time. And so there, as the merger progressed, so fast forward to 2008, 2009, we're putting the two airlines together, and so as the airlines came together and we're starting to forecast how this operation is going to run with these 13 different fleets, we did our very best and we set things up to succeed, but it didn't go so smoothly that first year of operation. So let me. I know we've got varying different backgrounds in the room. Just let me slow down for a second and give you just a couple of definitions. So when I talk about maintenance work, so maintenance on aircraft, there's different terms that I'll use in this presentation. There's really three big buckets of things that I'm going to talk about. And they're listed up here as preventative maintenance or time control maintenance, emergent maintenance, things that you know about, you don't have to fix them right now, but they're called MELs, and that stands for Minimum Equipment List, is an FAA term. These are things that you've deferred that you're going to fix later. And then there's something called the lower order check. So it's the basic servicing check of the aircraft. So if I were to give you just an example and relate it to your car, a lower order check would be along the lines of checking the oil. So every few days we have to go out and we do a basic servicing to an aircraft. So it's as simple as in your car, you go out and you check the oil and you know, you're good. Maybe you top it off, maybe you don't. In today's cars, we don't do a lot of that anymore, but that's what that would be similar to. Time control maintenance would be that you know your car has a certain maintenance requirement. So every 3,000 miles, maybe you're going to change your oil. So this is a planned event. You know it's coming. You know it's out there. There's a clock running of some kind. So it's mileage. On airplanes, it could be number of flight hours, number of flight cycles, which is a takeoff and a landing. It could be calendar time. You know, once a year you do certain things. These are all tracked in we have a technology system that tracks these things. So this is known work that's coming. And then the final one is the MEL. And this would be similar to, say, your check engine light in your car comes on. So that's telling you that there's a problem and it's something you need to take care of. You probably don't have to pull over at the moment, but you know, in the next day or so, you need to look at this thing. And so this is something that we found out there in service. It's okay to continue, but it has to be fixed at some point. The next term is AOS, which stands for Aircraft Out of Service. This is as simple as there's a broken airplane and it's not going to be available to dispatch. Okay, so for whatever reason, something has come up and the airplane is out of service. And then finally, sort of the thrust of where we see where you know these problems manifest themselves is in cancellations. And I know everyone's familiar with what a cancellation is. There's a lot of things that go on behind the scenes to try to prevent a cancellation. So we have spare aircraft. You know, if you're in one of our hubs, there's spare aircraft. If your airplane breaks, we'll bring another one. We have ability to swap airplanes between flights. There's a lot of things that we can do because of an out-of-service event to prevent a cancellation. But sort of as they compound, you run out of options and you eventually cancel flights. So let's talk just for a minute about this was the problem. So this chart shows across 2010, this is called our maintenance completion factor. Okay, this is the percentage of flights that we completed. And as you go along, you see the red line across the top. That's the goal. That's what we're aiming for. And as you go along the dark blue jagged line, that is an indication of our actual performance, and we've highlighted there the summer of 2010. And you can see the tremendous dip that we took in summer of 2010. Our goal was no more than 8 cancellations per day for mechanical reasons. So across these 2,500 flights that we operate, we're looking for 8 cancellations a day or less. We took 29.3. So at 29.3, you know, you can imagine the tension is high around Delta Airlines, and certainly covered by the Wall Street Journal and others that our performance in the summer of 2010 was less than stellar. So when you look at a cancellation and what drives a cancellation, we find that it's really 2 things. Number one, there's an AOS event, and those can be for varying things. I mean, we talked about something can break at departure time. But we also find that as some of this time-controlled maintenance or deferred maintenance, the MELs, as airplanes start getting loaded up with these requirements, with these things that need to be done, you know, they're expiring. As that happens, they can drive you into a situation where you're performing maintenance and the airplane's not available for the flight. So number one, AOS can happen because of non-routine things. Number two, it can happen because of things you knew about and you've gotten behind in what you're trying to do, and of course you're gonna have to stop the airplane and get it done. So you're unable to proactively repair. The other thing is aircraft out of service hours. So if you have an out-of-service event, a broken airplane, it might take 5 minutes to fix, and that's going to be no impact to the flight schedule. But if you don't have the parts, if you don't have the technical capability, if your inventory is in the wrong location, then your number of hours that event lasts can grow. And we found that cumulative hours of out-of-service time is really what correlates strongly to completion factor. So I think I should, at this point out that throughout the summer of 2010, there was no degradation whatsoever of the mechanical ability of the aircraft. The aircraft were as reliable as they always were. I mean, there are things that come up and things that break and things that happen. There was no sort of degradation of the inherent reliability of the aircraft. It was all in how we were able to recover and handle it in this new complex system that we were flying. So you would say, most of this stuff is known. Just be proactive about it. And I think this is where I've already alluded to. It's a fairly complex system. So if you talk about, there's sort of four major elements of how we have to accomplish work on an aircraft. The first is routing. And it's as simple as, think about, most factory environments where you're trying to optimize. You start off where you know where the factory is, right? You know where the parts need to be shipped, the people need to show up, all of those things. Our airplanes are moving. So what we're describing here is a system of maintenance bases that are spread all over the country, and the airplanes are moving freely between them. They're on a schedule, but schedules change and planes show up in different locations. So we generally know where an airplane's going to go for the next 3 days, but it's generally very low percentage reliable that it's going to stay on that rotation. So the airplane can shift. So number one, we got to route the airplane into maintenance. Our factory is always moving. Two, we've got to plan the work package. So we've got this list of things that need to be done. We have to look at the capacity in the station where the aircraft is headed, and we have to say this is how much of this work that they can get done. Third, we've got to make sure that we have all the parts available. And this, again, is the complexity of our factories moving all over the country. We've got to make sure that we align the people, the airplane, and the parts all in one location. And again, remember, Delta and Northwest Airlines did this successfully for 80 years. You put the two fleets together, you change where all the airplanes go, and suddenly things don't happen the way they used to. And then finally, we've got to have the right people be able to troubleshoot and repair the aircraft, receive the parts that came in, have the right airplane show up, and get the work done. So this is sort of day in and day out. None of this is going to change. This is the way you do maintenance in the line maintenance environment at an airline. And so what makes it worse is if you can't synchronize because so many things are expiring. So remember, I said a lot of the time control, it's known, but it's a matter of are you staying in front of that. So just a little bit on the inventory being in the wrong location. It's difficult to predict where the parts are going to be needed, especially when all your historical models are forecasting off of airlines that don't really fly the way they used to. And so we have good technology on both sides. We took the best of both Delta and Northwest technology, and we employed it. And it's not that neither airline ever changed where an airplane flies. That happens all the time in routine business of an airplane. It's just never quite to this magnitude. Everything was different. Things, airplanes that under the Northwest system had only flown between, from Minneapolis somewhere or from Detroit somewhere and back for their entire life with the airline now didn't go to Minneapolis or Detroit at all, and vice versa on the Delta side. So it's a matter of your forecasting models didn't work. So we've got a central warehouse and we've got line station stock rooms. So big central warehouse in Atlanta, big central warehouse in Minneapolis, and then across our 29 domestic stations, there's certain inventory that's stocked there. So we're managing these inventory levels very manually for the summer of 2010 because our forecasting is not, we don't have enough data to forecast yet. We don't like what we're seeing. We're making reactionary decisions. This is going to sound familiar perhaps to a lot of you. A lot of management intervention in what our materials plan should be. So a lot of, an airplane shows up broken one morning and the next thing you know, we stock 10 parts of that kind in that station, right? So reactionary, pushing parts into places with not really any data. We also were plagued by a very slow replenishment cycle. Never before have we needed to replenish our line station inventory quickly. So, bottom line, the inventory is really the buffer for us. So as airplanes move around and it's not planned and it's, the airplane doesn't show up in the station we want it to be, inventory is our buffer, and we had lost that ability to buffer. So the solution is obvious. It certainly was obvious to realization. It was obvious to me after they explained it to me. We've got to clean the airplanes deeper, which means eliminate as far out in the future as we can on time control maintenance. So previously, when our planning department was looking at the work that had to be done, they would clean up anything on that aircraft that was expiring in about the next 2.5 days. So 2.5 days of clean, and then that airplane would have something that was expiring again. So we set up to do that. Our initial plan was, let's clean them up for 15 days. Let's give ourselves 2 solid weeks of this airplane doesn't need to see maintenance for any routine or planned event, only for just routine, checking the oil and kicking the tires and that sort of thing. Secondly, we looked at the way we stocked parts. We wanted to level out our inventory across the system, and we had to figure out a way to replenish faster. So it was going to be imperative, if we weren't going to go double our inventory costs, it was going to be imperative that we redistribute our inventory and lower inventory levels and then be able to replenish on a much quicker schedule, which ended up being a 24-hour replenishment. So let's talk about the first one. This is, how did we clean the airplanes deeper? So again, we didn't want to go out and hire 1,000 additional mechanics. I mean, we felt like we had the number of mechanics to do the work. It was about synchronizing. So if the chart that we're showing here, across the x-axis, we're indicating 350 aircraft. That's what was the number of aircraft in a maintenance station every night. So of Delta's 700 and something airplanes, about half of them, 350, were in one of the 29 domestic maintenance stations every night. And so our previous plan had been, on every airplane, you did a lower order check. So you did some general checking and servicing. You did some time controls. On average, it was about 2.5 days worth of time controls. And you did as many of these outstanding MELs as you could. So these were your non-routine findings you had deferred. So on every airplane, you kind of customized the work scope. You did as much as you could, and you spread your resources across all 350 aircraft. And this was generating an airplane out of maintenance that was good for about 2.5 days. So we changed that a little bit. First of all, everything still needs a lower order check. I mean, this is part of our maintenance program. It's required. So all 350 airplanes we're going to go out and do a servicing on. But then we reduced the number of airplanes that we intended to focus on with MELs. So instead of all 350, we reduced that down to about 200. So we picked 200 airplanes that we're targeting to put in maintenance that have an outstanding MEL on it, so that we could drive some focus to making sure the parts are available, making sure that we get the people, the airplane, and the parts aligned in the right location. And then finally, that freed up capacity to focus only 60 airplanes on time control maintenance. Again, the routine, scheduled, it's coming. But when we did it this time, we didn't clean it up for 2.5 days. We cleaned it up for 15 days. So a tremendously different change in our philosophy of how we're going to work these aircraft. And we could have a whole separate discussion on the change management of this. I mean, you have mechanics that for their entire career have done the same thing to every airplane every night, and that, as indicated in the top bar. And we're saying, no, on some airplanes, we don't want you to work it. It may have an MEL on it. Don't work it. It may have a time control expiring in 5 days. Don't work it. We are only going to work the things that we tell you to work, because it's imperative that we keep the whip down and then we man load those things that we're really trying to accomplish. So what else did this give us? And I already alluded to this on the MELs. It reduced whip, so it allows us to set up a slotting plan. Okay, so the slotting was a more rigorous definition of these 200 airplanes that had outstanding MELs. All the way up to the 350, the additional 150 airplanes, we don't care which ones show up. Our maintenance program says, whatever you got, go touch those airplanes. That's fine. These 200 require planning. These 200 require that we get the parts aligned and we have the resources to get it done. So now, starting sometime in the midday, we've got a slotting list of these are the airplanes coming in maintenance tonight. So, I think the benefits here are going to be obvious. Increased focus for planning. So planning now knows what to expend their resources on and spend their energy on. And they're developing the right work package, the right list of things that we need to go do. The materials team is able to really focus on only 200 aircraft. So instead of 350, we cut their work almost in half in the airplanes that they had to focus on getting the right parts to the right place. In the maintenance station, instead of spreading our resources across all 350 aircraft, you're really concentrating on 200, and you're able to appropriately staff and man each aircraft for that kind of work. And then by the time you get this system running, there's a limited number of aircraft that are expiring. So you're not constantly driving your routing team to get an airplane in because you only cleaned it up 2.5 days ago. Instead, things are very clean. You've got a lot of buffer. This provides you the buffer of time. So if something goes wrong, you have a big weather system come in and you can't get your airplane where you thought, you have 15 days and you can recover that buffer. So for the part shortage, the solution was also simple. We're actually going to increase, and this would make the CFO at Delta cringe, we're increasing the number of SKUs that we stock. So we already own hundreds of millions of dollars of inventory. In our plan, we told them we're going to put more inventory out there. But actually, it's only in the number of part numbers. So we increased in our 29 stations the number of part numbers that we stocked, but we funded that by lowering the actual number of parts that are in the bin. So fairly simple. Increase the SKUs, lower the total inventory, and you can do that because you've got a 24-hour replenishment. So every day you use one, you replace one. I mean, very simple. You've got it at the station, and you're able to replenish in 24 hours. So all this together, here are our results. So the red line is the summer of 2011. So we spent the end of 2010 and the spring of 2011 getting these new processes in place and getting everybody lined up and ready to go, and delivered far better performance. So whereas we had 29 cancellations in the summer of 2010, we averaged 11.2 per day, a 62% decrease in the summer of 2011. Our goal was 8 per day. We've got some more work to go, and we think we know how to do that. This was really driven by 17% fewer AOS events. So again, I would attribute that to the fact that you don't have airplanes expiring out there. You don't have known routine maintenance running out of time and sort of dropping on you when you least expect it. And then the entire solution gave us 21% fewer AOS hours. And that's really a combination of both the planning, the cleaning, as well as the materials solution, having more parts available in more stations. So just phenomenal results. And we can go further. We think that we learned enough about this, what we were calling deep cleaning and cleaning 15 days. We experimented with one of our fleets and we cleaned 45 days. And we did nothing else to it. We changed nothing about how the airplane flew. We changed nothing about inventory. We cleaned 45 days as a test. And the completion factor and departure performance, the on-time departure performance, went up on that fleet. And so, for 2012, I think when we're looking at, we were at 11.2 cancellations a day. We'd like to get to about 8. We think with no other changes except actually cleaning deeper on our time control maintenance, that we'll be able to make that jump. So a huge success for us. So let's see. We talked about the engine and component area from the 2007-2008 implementation. The line maintenance implementation returned a 62% reduction in maintenance cancellations. And so now we'll talk for a minute about base maintenance. And I think I'll just keep rolling, Gary, and you jump up here when you jump up when I start making you nervous. So base maintenance at Delta Tech Ops is what you would think of as hangar maintenance. So these are visits that are not done out in 29 different line stations. These are done primarily at our main headquarters in Atlanta, Georgia. We have a base maintenance facility in Minneapolis as well, but the bulk of the work is done in Atlanta, Georgia right now. And this is everything from, we call letter checks up here. These are not full aircraft overhauls, but they're your checks that come due, say, every 18 months on an aircraft. And it takes an airplane out of service for anywhere from 7 days, sort of on the short end, up to 21, 22 days on the long end, and generates a few thousand maintenance hours of work to do one of these heavier checks. We also, in this facility, do modifications, landing gear changes. These are things that just can't be done out on the line environment. They can't be done while the airplane's sitting at a gate at an airport. And so those are done in base maintenance. I'd also point out that we have, again, a substantial customer base that brings their aircraft. So these are operators, these are leasing companies, the military. So we do several, over 100 different base maintenance customers in Atlanta, Georgia, and we have one new customer or 2 new customers in Minneapolis as well. So the business needs are pretty straightforward. What our customers need are shorter turn times. So an airplane on the ground is an airplane not making money, and when they bring it into a hangar visit, they want it to go as quickly as possible. But they also need predictable turn times. So it's not just, give me your shortest estimates you can, and then sometimes you hit it and sometimes you don't. It's very important that whatever you agree to is what you hit. So we'd like them to be short, but they've got to be consistent. Secondly, for Delta, we set a goal that we wanted to increase revenue by 30%, and we want to increase our profit margin by 20%. So I will tell you, the longer an airplane sits on the ground, the longer it accumulates manpower. It just happens. You sit there and it becomes, there's wasteful things that start happening. So having a good, smooth flow is really what we're looking for. And so our solution is we targeted increasing our throughput by 30%. So on essentially the same capacity, we're going to push through 30% more airplanes. So let me give you an idea of how the before implementation, an aircraft flow would occur. So this is a very simple view of one aircraft visit getting what we'll call a C-check. So this is a mid-level, say this is a 17-day visit, and we sort of start with inspection. So you look at that bottom line, which is inspection, assessment, and parts ordering. So your inspectors go out and start hitting the airplane, and they're timing to be done with inspection, at some point way out in the aircraft visit. So that's going on, and as they start generating things start getting assessed, and then maintenance starts picking up and accomplishing maintenance. It's a very slow process. It's one where you feel like a lot of work is starting to happen, but it's not focused work. And in a scenario like this, you could end up with one inspector who's doing all the inspection of this aircraft. So, this inspector may be thinking, I've got a couple of weeks to get the inspection done. Well, you can see as you get out further to the right and closer to the final, close the airplane up, go test it, make sure it's ready, and return it to the customer, you're still inspecting things. You're still finding things, and you find yourself on day 15 of the visit getting a new non-routine identified that now you have to assess what's the repair going to be, and do we have the parts, and then get maintenance assigned, and you end up with a scramble at the end. And I can tell you, this is the way maintenance has been done for decades, and this is a huge area of improvement, area of opportunity. So again, late definition of scope is a big problem, leads to late parts ordering. You've got your resources spread thin across the aircraft, and that will lead to your resources spread thin across the entire hangar. So this is the new aircraft flow. This is what we came up with working with Realization on how we're going to flow the airplane. Number one, and this is, I'll preface this with, it's a partnership with our customers. Our customers have to be bought into this, and they have to see the benefits of it. But number one, 7 days prior to the aircraft getting there, we're in what's called this launch phase. So in this phase, we're defining a very clear work definition of scope on the aircraft. Okay, a lot of airplane operators are famous for, once it gets in the hangar, they start thinking of all the other things that they'd like to have done to the aircraft, which that's a whole separate business model. And but this is specifically, you've got a scope of work. Let's get it defined, and let's establish what we're calling the full kit one. So this is the list of parts that, based on this scheduled maintenance, we know we're going to need. And we require that those materials, this definition be done, and those materials be on dock 7 days in advance. And I'll tell you, so far through this implementation with our customers, this has been a huge success. And I would say we're over 95% compliant with this, 95% compliant. The second step is, after we induct the aircraft, we pour the inspectors on. So this is no longer one inspector hits the aircraft. It's all available inspectors assigned to this area. So everyone hits the aircraft, and in a matter of a couple of days, all the inspection is done. That flows right into the assessment. So our lead mechanics, they take the inspection findings, and the lead mechanics are the ones saying, this is how we need to go fix it. These are the parts that we're going to need. It's at this point, and again, we pour the resources onto that step. These things, we want this all defined and done very quickly, so that we can establish what's called the full kit 2. Again, full kit 2, some of those parts, perhaps Delta as the MRO is going to provide to our customers. Some of those parts the customers are going to have to come up with. It's customer-specific inventory. Again, you got to have the customer bought into that. We want that full kit 2 established prior to us attacking the aircraft. So before we spend our precious resources and send all our mechanics out to perform the maintenance on the aircraft, we want all the parts available and the full kit 2 complete. This one is harder because the fuse on this is much shorter from the time you find it until you need them. And so we're currently running about 60% on full kit 2. our ability to get our customers to sort of get everything back to us and ready to go. So it's much better. It's not perfect, but it's getting there. So then we attack the aircraft, and this is where we really pour on the manpower and complete all the repairs as quickly as possible. So you're no longer finding new scope at the end. You're no longer, having surprises right before close up and test. And then finally you get out and you do whether your test flight is required or whatever is required at the end of the visit. So much better flow, much better process. A couple of things to mention. It's not just managing the one aircraft. Then it's how do you flow those aircraft together with multiple airplanes in the hangar at the same time. And so if you look at the chart on the top right is hard to see. But the top line, the top bar indicates individual aircraft visits, multiple of them. And so the key is to stagger them so no more than one aircraft is in WIP for these critical functions at any given time. So for the inspection, you don't want 2 airplanes showing up the same day and needing all the inspectors because we spread the resources thin. So you want them lined up to where inspection hits one aircraft and then they can flow to the next airplane. Assessment happens on an airplane, then they flow to the next airplane. So pretty simple concept, but this is one where your sales department will want to drop all the airplanes in on the same day, and you have to tell them, you stagger them like this, and I'll actually produce more airplanes quicker for you. And so that's been a big success. The next graph down shows these shorter visits. So these are visits that are perhaps, a day or 2, 3 days long, maybe a landing gear change or something like that. And these visits you're going to manage with just a straight dedicated capacity, and it's important just to note that they just can't all show up at the same time. There has to be some kind of synchronization there. These two things together really give you a good view of your manpower requirements. They allow you to buffer with additional resources where you need to. You can bring in additional manpower and keep things flowing. The second chart just flags the 2 full kitting areas, full kit 1 and full kit 2. You've got to establish that, and you've got to really hold the line on it, and you've got to have a partnership with your customers, and your customers have to buy into to the full kitting process. And I can't stress enough how historically it's left to the MRO to figure that out. And every day that's wasted is actually a day you're costing the customer money. And then finally, again with the partnership, all of this setup allows for you setting aggressive goals at each step in the way. So you're not just setting an aggressive 17-day turn time, you're setting an aggressive 1-day inspection. So every step in the process has an aggressive turn time or an aggressive time for that segment. And then you buffer the entire visit at the end. So you build in some buffer of time at the end, and we've also implemented Concerto in this process, and you can see the bottom right-hand chart is a snapshot from Concerto. As we're measuring our progress on the critical chain, we're also measuring the buffer consumption. It's key that we pull our customers into that. It's key that the customers understand the buffer consumption and understand sort of how they affect that. Failure for a customer to make decisions quickly or provide parts quickly, we're consuming buffer. And so all of these things together have produced really good results. So if you look at, again, this was a July snapshot of 2010 and a July snapshot of 2011. And you can look at, in the 2010 performance, we did about 25,000 hours of C-check maintenance with 164 resources. This year we did about almost 31,000 hours of maintenance with fewer resources, 151. If you look at the on-time delivery, we only completed 1 of 7 visits last year on time. This time we completed 6 of 9. And I'll tell you, things are going to come up. Non-routine things are going to come up that drive the visit out, and you're going to struggle to make it. But we think we can still get it better. We think we can get a lot closer to 9 out of 9 than 6 out of 9. And then you look at the average lateness. Last year we were 5.4 days late on average. This year only 3 days late on average. So a tremendous improvement. So again, we've done really 3 separate engagements with realization. And I think that the results speak for themselves. And I would be remiss if I didn't at least put up the team names. And I won't read through all of these. I will tell you 2 of the Delta team members I've already mentioned, Matt and Gary, are both here today and can maybe help us answer some questions. I can't say enough about the realization team. The solutions in all 3 of these cases, 2 of which we talked about today, it's like their trademark is it's just simple. I mean, there was nothing, it wasn't a silver bullet other than We're going to do this in a very logical, simple way. I have to praise them for their great teachers. They've taught a lot of people. They don't leave you sort of where you can't do this, you can't help yourself any further. It's been a great experience working with them, and it's a great group of people.